To calculate the volumetric displacement of this gear pump, volumetric displacement of this gear pump VD, so that we can calculate the flow rate. So if we know the volumetric displacement, we can multiply by the revolution per minute to get the flow rate. Now, to calculate the volumetric flow rate, if you look at this vacuum spaces where the fluid is trapped and gone, there is a similar, the gear profile. If you look at the gear profile mesh, it's basically the same as the gear profile. So this vacuum space can be is very close to the gear profile. So what we can say is, if we can say that, basically, if this is the internal, so for example, like this, so the inner circle and the outer circle like this, like this. So we can imagine that there is this two circle, and because of the two gears, we can say this one of these vacuum space is kind of vacuum taken by this gear. So we can see that the entire space is vacuum. So to calculate the volumetric displacement, we can imagine that we have a thing something like this. So the outside diameter is d O, and then the inside diameter is di. So we can calculate the area. And then if this gear is, say, it has a width, say for example, the width of this gear is about L. So we can consider this as a cylinder. So to calculate the volumetric displacement BD, and say VD equals pi by 4, the area times the height. So pi by 4, the outer square minus the inner square times L. So that is the volumetric displacement. Now this, if it's in inches, for example, so this is an inch square and this is an inch, so the unit will be inch cube, and then I would like to call the inch cube per rev. So every revolution there will be about pi by 4 VD, pi by 4 d square, outer diameter square minus inner diameter square times length. So this much volume will be expelled every revolution. Every revolution. So if we want to calculate the flow rate, for example, Q, so VD is in inch cube per rev. Then if we multiply by RPM, revolution per minute, that is revolution per minute. So we can have VD is times N and then inch cube per minute. Now, if we want to have that in gallon per minute, simply we can convert this and make it gallon per minute. So to make gallon per minute, what we can do, Q is equal to VDN and then inch cube per minute. We know that 1 gallon is 231 inch cube. So basically this will be then VDN by 231 gallon per minute. This is the theoretical flow rate, because we used calculate using the gear profile, theoretical flow rate. And then when this is in inch cube per rev and N is in RPM. Now if you try to calculate this same, if you try to calculate the displacement for this vane pump, this one, to calculate the, so this rotor is a solid shaft inside, and this vacuum space is basically where the fluid is gonna be trapped. So to calculate the total amount fluid trapped if we ignore the vane width, which is very negligible compared to the vacuum space, we can calculate the displacement like pi by 4 d square cam diameter instead of inner outer diameter on this vane pump. This is called, the outside is called cam, and then the inside piece is called rotor. So we can say cam diameter is square minus rotor diameter is square times the length. Let's assume that this vane pump is width is L, like this. So basically a cylindrical piece like this. Like this. So this is the width of the vane, like that. So that's the volumetric displacement. We can do a little bit of calculation here. If we want to calculate the maximum eccentricity of this piece, that would be the rotor cam radius minus the rotor radius. So it's going to be d rotor minus d cam minus d rotor divided by 2. If you rearrange this pi by 2, and then this one we can rearrange dc plus dr, and then dc minus dr, and then this divide by 2 here and L. So Vd, we can write that dc minus r by 2, dr by 2 is basically eccentricity. Instead of max, we want to develop a generic formula. So we can write like this, dc plus dr, and then E, and then L. So to calculate max and eccentricity, use this equation. But if it's any other eccentricity, you should use this equation, and Vd is there. And similarly, this Vd can be converted to theoretical flow rate by just simply multiplying by this. So that would be the theoretical flow rate, and whatever conversion you need to do. If it's in gallon per minute or in international unit, meter cube per second, we can convert whatever is needed. So this is for vane. What you need to understand here, this displacement volume, how to use that equation, how that thing comes. Same for this gear pump too. All right.